Stunt car driven off a cliff, hits the water 4.5 seconds later. Initial velocity of 20 meters per second, an angle of 37 degrees. So as with all of these problems, it never hurts to start by determining what the velocity in the x and the y direction are. Velocity in the x direction, v0 cosine theta. So that looks like 20 meters per second. Cosine 37 degrees. So that gives me 16 meters per second. Velocity in the y direction, and that's the initial velocity in the y direction, is v0 sine theta. 20 sine 37 degrees is 12 meters per second. And just to remember, that's velocity as a function of time is 12 meters per second minus 10t. The velocity in the y direction is not constant. We want to know what the maximum height of the car is, the range, the height of the cliff, how high the cliff is, and the velocity on impact with the water. One of the first things you've got to do when you do a problem like this is determine what you want to call height of zero. And I'm going to choose, for no great reason, I'm going to say that this y here is 0. And so that when we get a final height, or when we do a few seconds from now, when I determine how high the cliff is, I'm going to come up with a negative number for the height. For maximum height, as we've done many times before, the simplest thing often is just to say t equals v0y divided by 10 meters per second squared. So that says that it's going to take 1.2 seconds to get to the top of the flight. And from that, we can say the average velocity is 12 plus 0 divided by 2, 6 meters per second. So the height is equal to the velocity, average velocity, 6 meters per second, multiplied by time, 1.2 seconds. That's going to give me 7.2 meters. It also would have been perfectly okay to do the y equals y0, v0 on the y times t, 1/2 at squared, or v squared is v0 in the y direction squared plus 2a delta y. All of them would have given us the same answer. And you can kind of do that on your own if you want. So next question is going to be, what are we going to get for range? Range, horizontal distance. So you'll recall velocity in the x direction is 16 meters per second, time of 4.5 seconds. So that's going to give me 16 times 4.5 is, so the horizontal distance, the range is going to be the velocity in the x direction, range in the x direction, velocity in the x direction times t, 16 times 4.5, which is 72 meters. And then I want to know the height of the cliff. So there's a couple ways of doing this. And I'm going to do kind of the most straightforward mathematical way, which is to say that y is y0 v0y times t 1/2 at squared, where we know y0 is 0, v0y is 12 meters per second, acceleration is minus 10 meters per second squared, and I'm just going to plug everything in. And t is 4.5 seconds. So y is 0 plus 12 meters per second times 4.5, 1/2 minus 10, 4.5 quantity squared. And if we do this out, we end up with minus, plug that into here, and we do the math out, we get a minus 47, minus 47.25 meters, which says that the height of the cliff is 47.25 meters. It says that the height above the maximum height is 7.2 meters. There's another way that we can look at this, and that is to say the following. We can say that the total time is 4.5 seconds. The time to get to the top is 1.2 seconds. So therefore, the time for it to fall, this is the kind of going up time. This is the going down time. And remember that from the top, the velocity is equal to 0. So really effectively what we have is just an object dropping. So I can just do distance is 1/2 at squared. Distance is 1/2 10 3.3 squared. If I do that out, I come up with a distance of 54.45 meters. And then from that, I'll subtract the 7.2 meters that was the max height. Minus 7.2. And I get 47.25 meters, just as I would have expected. So the velocity on impact. Well, remember that it had a velocity in the x direction. The velocity in the x direction was 16 meters per second. The velocity in the y direction is v0y minus 10t. So that's going to give me 12 minus 45. So 12 minus 45 is minus 33 meters per second. Magnitude of the velocity is therefore 16 squared minus, 16 squared plus 33 squared. Hold on a second. So I get a velocity of 36.7 meters per second. And again, I've got 16 in this direction, not drawn to scale, 33 in that direction. So the angle is going to be arctangent of 33 over 16. So clearly I'll get a number that's bigger than minus 45. That's what we get. 33 divided by 16. Get an angle of, it's minus there, minus 64.13 degrees. So I think that's it. Thank you.